Hello everyone, welcome to my channel. In this series of AgentKit, we will be talking about models, reasoning and tool calling. In this video, we are going to talk about something that looks simple on the surface but actually changes how you design AI systems completely. And that is the relationship between models, reasoning and tool calling. For a long time, we treated large language models as the product. We asked a question and we waited for an answer. But real systems don't work like conversations. Real systems work like processes. They need to understand context, they need to make decisions, they need to interact with real data. And most importantly, they need to change direction when something doesn't go as expected. This is where agent-based architecture comes in. In AgentKit, we don't treat the model as a chatbot. We treat it as one part of a larger thinking system. In the next few slides, we'll slowly break this down, what the model actually does, why reasoning matters, how tool calling works, and how all of this comes together to create real autonomy. Think of this video as building the mental model for agents, not code, not APIs, just clear architectural thinking. Let's start with how most traditional AI applications are built. The structure is very simple. You have a model and you have a prompt. You send input, you get output. And for many use cases, that works. But now let's look at real world problems. Real problems are never solved in a single step. They are multi-step by nature. You need to gather information, you need to validate assumptions, and you need to check constraints. Finally, you need to reconsider decisions. A single prompt response cycle cannot handle this reliably. That's why agent systems look different. An agent system is not just a model, it's a combination of three things: the model, reasoning, tools. Model is nothing but which provides intelligence, reasoning, which provides structure and decision making. Tools helps to connect the agent to the real world. This is the key shift. Agents don't just answer, they think, they decide, they act, and then they rethink based on what happened. AgentKit is designed around this idea. It doesn't force everything into a single prompt. It gives you clean separation between thinking, acting, and observing. And once you see this separation clearly, designing agent systems becomes much more intuitive. One of the most important ideas in agent architecture is the model is the brain, not the worker. In AgentKit, the model's primary role is reasoning. It understands the problem, it evaluates opinions and options, it decides what should happen next. What it does not do is execution. It does not directly call databases, it does not directly hit APIs, and it does not perform calculations itself. Instead, the model chooses what needs to be done, not how it is done. This separation is extremely powerful because now you can use these different models for different strengths. A small model is perfect for lightweight tasks, things like classification, routing, and intent detection. A medium model is better suited for planning and structured reasoning, whereas a large model is reserved for complex decisions, ambiguity, trade-offs, ethical judgment, and critical analysis. AgentKit allows you to swap models without rewriting the system. That means you are designing systems, not model-dependent hacks. This is how you scale intelligence responsibly. If models are the brain, then reasoning is the thinking process. Reasoning is what turns intelligence into structure. At its core, reasoning follows a loop. First, the problem is broken into steps. Then, the agent decides the next action. After acting, it reflects on the result. Based on that reflection, it adjusts strategy. And this repeats until the goal is achieved. This loop is invisible to everyone in traditional chatbot applications, but it's absolutely central in agent systems. Without reasoning, a model reacts. With reasoning, an agent plans. AgentKit makes this loop explicit. You can observe it, you can control it, and you can constrain it. This is what makes agents reliable in complex environments. Reasoning is not about being smart, it's about being deliberate. Let's make this concrete with a reasoning example. Imagine a user asks, create a treatment plan. A traditional model might immediately generate an answer, but an agent does something very different. First, it tries to understand the patient context. Who is the patient? What are the constraints? What data is missing? Next, it checks medical guidelines, not assumptions, but authoritative references. Then it identifies risks, contradictions, side effects, and special conditions. And after that, it validates bias. Is this recommendation favoring a certain demographic? Is anything being overlooked? Only after all this does it produce a recommendation. This is reasoning in action. Not guessing, not generating, but thinking step by step. This is why agents are suitable for high stakes domains. Reasoning is alone is not enough. To operate in real world, agents need tools. Tools are things like APIs, databases, and services. The important detail here is control. The model does not randomly call tools. It decides when a tool is needed. When a tool is called, it returns structured output, not free text. The agent then reasons on that output and decides the next step. This creates a clean, auditable flow. For example, the agent might call a patient record lookup tool, a risk scoring service, or a policy compliance checker. Each tool does one job well. AgentKit keeps tool usage safe, explicit, and traceable. This is how you turn thoughts into actions responsibly. Finally, let's talk about reasoning and tools. Real autonomy emerges when reasoning and tools work together. Reasoning chooses which tool to use, tools return new context. That context improves the next reasoning step. This feedback loop is what makes agents adaptive. If an API fails, the agent can retry. If a strategy doesn't work, the agent can switch approaches. If information is missing, the agent can ask for clarification. But autonomy does not mean chaos. AgentKit enforces guardrails. AgentKit operates inside defined boundaries. They can explore but not escape. This balance is critical for production systems. Intelligence without control is dangerous. Control without intelligence is useless. Agents need both. Not every task deserves the same level of intelligence. Simple tasks should use small models. Planning requires reasoning focused models. Critical decisions deserve stronger models. In every case, cost matters and latency and reliability matters a lot. AgentKit supports model orchestration. A router agent might use a small model, whereas a planner agent uses a reasoning model. In the same way, a critic agent can use high accuracy model. This is system level optimization. You are no longer asking which model is best. You are asking which model fits this role. That's mature architecture. Let's bring everything together. The model provides intelligence, reasoning provides structure, tools provide action. Feedback improves decisions, observability ensures safety. This is the AgentKit mental model. Agents are not prompts, they are systems that think over time. Once you internalize this, designing agents becomes a design problem, not a prompt problem. In the next videos, we will go deeper into agent patterns and real world architectures built on these foundations. Thank you, everyone. Hello, everyone.